Okay, while the last people are setting up, I would like to ask you to share the charging stations with others if they are lacking power so that everybody can participate. I was told that everybody of you has an Anaconda installation ready, and I hope that this is the case. If not, then it would be a bit too much to download on the conference Wi-Fi. I mean, we can try to crash the Wi-Fi, would be a nice challenge. I am very honored to have that many people here. First question, who has worked with Jupyter notebooks? Who has worked more than 3 years with Jupyter notebooks? And who works daily with them? Okay, I want after the talk that everybody raises his hands on the question how to use Jupyter notebooks daily. Because today I want to give you like a lot of things, so it's like the bird view. We sometimes go into details on how practical work is being done with Jupyter notebooks. And so I have this cheesy about me slide. So for those that do not know me, I'm a senior data scientist at New Yorker. That is a German fashion company, mainly for people in their teenager ages. And the unique thing about it is that we only have a brick and mortar store. So it's really only no e-commerce, just brick and mortar. Mainly I'm optimizing the prices, the redistributions of items between the stores and the order and shipment on quantities such as demand prediction. We do not do fashion trend prediction right now, which some of the startups are doing. I am freelancing for Data Science Retreat. Who knows Data Science Retreat? Okay, cool. So that's the logo on the bottom right, and that's a program that teaches people in 3 months on to be a data scientist. So what we produce we call freshly minted data scientists, and they are usually being hired straight away from the program. It goes 3 months. And it gives an overview about machine learning, practical stuff, big data technologies, and with relation to Python, it's all given in Python. Okay. I started a PhD, but I'm a dropout, which I did at the University of Potsdam. I've used to be teaching. I was a software developer in text analytics. So that was about optimization of technical documents. So if you are buying a motorcycle from Harley-Davidson, or some of the documentation at Microsoft or Google is being optimized by the software I have being a part of developing it. I've also worked in predictive maintenance, so that's a question on, it's a very active area. By the way, does somebody work in predictive maintenance right now? Yeah. So the challenge is you want to figure out from time series you're measuring in industrial equipment, when do they blow up? So I had data from a German nuclear power plant. I'm still being under NDA. I can't tell you what the results were, but just feel safe enough. I think we will survive. And also actually the Deutsche Bahn, the railroad, is doing predictive maintenance on their toilets, because you wouldn't imagine that, but the toilets are a huge issue on German railways. Who would have known? Also, what would be interesting for you is that I'm the organizer of the Kaggle Berlin group. Since I was outside of Berlin due to business reasons the last months, I couldn't host one, but very soon we will host again. If you don't know Kaggle, Kaggle is a data science platform where you can compete, and it's mainly about solving different kinds of problems, and people mainly use it for learning. There are also some people from Berlin, like Abhishek. I don't know whether Abhishek is here. Are you here somewhere? No, I think he's preparing his talk, because he's so he's giving a talk this weekend, and I know that he started yesterday preparing it. So apparently he's not here, and he was the top 3, one of the top 3 worldwide Kagglers on that platform, and he also won some contests. So if you meet him, he has a lot of knowledge regarding machine learning. So today I want to show you what the Jupyter project offers. And it's a community project, one of the many. You know others, such as Pandas or Scikit-learn, very famous. Many people use them. Or NumPy that wrap the traditional numerical linear algebra routines originally written in Fortran. And I start at the very bottom level. So if you haven't been using Jupyter notebooks yet, I give a very short walkthrough regarding the basics, just that everybody is on the same level. Then I show you some advanced tricks, such as how would you debug and profile notebooks. And for the people who have been working for a while, I would like to know after the talk whether you have learned something new that you didn't know before. I show you some configuration tricks, which for some reason many people do not use. There are certain configurations you can make for your plots, etc., that increases the quality of the diagrams, etc., that you're using dramatically. And if you're going for presentations as a data scientist, if you're presenting to business owners, or if you're presenting in academia, you should use vector graphics. You should use high quality plots, because if you wouldn't, it would leave a negative picture behind that, because people will wonder if the graphics are that bad, are the results maybe also bad? And that immediately sheds a bad light onto your results and work as a data scientist. And you don't have to do it all the time. I have prepared you a snippet script that you can look through, adjust for your needs. Mainly depends on your printer and your screen settings that you can then always reuse. And if you're working in a data science team, only one of your team has to do it. Okay? And I want to make you aware of the plugin ecosystem of Jupyter, which has been growing dramatically. For instance, there is a plugin I got to know like a few months ago that makes you able to like have a chapter of contents of your notebooks. So on the left-hand side, I will show you later, you have like all your sections heading, and you can click them to jump onto that section, which I'm now using every day. And as a drawback, my notebooks have increased in size by 10 or 20. So it will immediately, if you start using these plugins and adjust Jupyter to your needs, change your workflow. So I just want to share with you what I've learned over the time. So if you're new, that you can profit from my experience. And you can find all the material on this GitHub, which is my personal account. And you do it on the project Leveling Up Jupyter. I hope if somebody cannot open it or doesn't know how to clone a repo, please raise your hands. You can always ask questions. I like interactivity. Okay, so some people are typing. The slides are not being designed to be terribly useful. So I will send them in, but you really should stick with the repo, which I will also extend and fix after the talk, if you want to get anything useful out of the talk. Everyone all right? Cool. Good. Raise your hands if you couldn't do it, and we can fix that. Disclaimer, the tutorial might seem a bit unstructured. Actually, I've put a lot of thought into it, but it's if you're giving like an overview about like such a large topic, it's very hard to answer these decision problems, how deep you go in the respective topic. I want you to like get an overview what there is and see one example usage of it. Right, so that when you know you need something, you know where to look at, and this may seem a bit unstructured or chaotic for some. Jupyter is a project that was forked from IPython in 2014. The name stands for Julia, Python, and R. I don't know any person that uses Julia, but I think in this room just before there was a talk about Julia. R is a bit on the decreasing trend there are still great libraries on R, and I think the built-in visualization tools in R are great. So if you go with a single machine, I think R is still viable. People from statistics departments still like R, but I think the rest of the world switched to Python from my filter bubble. And the community is very active. You also see like very diverse. Jupyter is partitioned into sub-projects, such as the notebook on the left-hand side. There's a certain core, the code for conversion. So I will show you in a second. These notebooks, which are web-based, can be converted into other formats, such as HTML or PDF, which is useful if you want to present your results. And yeah, there are also some other new projects like Jupyter Lab, which I haven't been using so far, and I'm not going into details about that. So we will mainly talk about the notebook sub-project. There's actually a conference just for Jupyter, which shows you how much there is to talk about in Jupyter. And I've made a screenshot. I hope you are admiring my screenshotting skills, because it was actually a background video and I had to time it. And it's actually, I think today ends the early pricing. It's in London, so if you're interested in getting your work group set up in Jupyter as a decision maker, I strongly advise you to go there. Also, you can meet key people in the development community. And when I saw the slide, it looks like an advertisement, right? So all the logos like PyData, New Yorker, Data Science Retreat, JupyterCon. Who knows? So why notebooks? One key thing is to collaborate with others. Of course, we have always been exchanging source code with each other. Notebooks are a bit more because they also carry documentation and image data. Presentation, so coming from your results, you can generate presentations directly. This is super helpful, which you have to do as a data scientist, and it's always a lot of work to copy-paste pictures into PowerPoint or whatever you are using. Reproducibility is a huge thing, which I do think that many people underestimate. And by that I mean if you are taking a notebook, that you can reproduce the result on your machine. And there are ways to help you with that, and that is called under the term isolation. And that's, for instance, using Docker images. And in the talk, I've made you 2 Docker files which carry notebooks. There are more. They are linked in the sources. If you happen to use technologies such as TensorFlow and Spark, you can directly run up these containers and use them from your notebooks. This is super helpful. So my team currently, we are 8 data scientists. We all use the same Jupyter notebook setup, so that everybody can run every notebook on the cluster and obtain the same results. And also flexibility. So next to Julia, which nobody uses, that's why I didn't mention it, R and Python, there's also Scala, which is like really helpful. And I think some other, so you can actually write Haskell to troll your team. There are kernels for that, if you're into that. Nothing against Haskell, it's great. So this is a screenshot I've made. I hope you can see it. This is from a colleague of mine. This is an analysis that's being done. I've grayed out some areas because I would get sued for showing this data. You see that the quality of the plots has been adjusted. On the left-hand side, you, for example, see a chapter of contents. You see that he's using own font, like in your editor. So you know there's a plethora of color schemes, like I think Solarized Dark and Light are very used most often. So people change their colors for night because it's less straining on the eyes. And you see here, it's hard to read, but he's actually writing Spark code. So everything that he runs here and on the nodes is actually computed on a cluster with, I think we have 20 machines. And if there are multiple people working at once on that, then the resources are being allocated dynamically. Okay, so the Jupyter Notebook server is running on the cluster, but he's using his laptop to access the web-based interface. And this is how many groups are working nowadays. Questions so far? Okay. I want to spend some time before we go into the practical part to say like credit where credit is due. So I've learned a lot by a talk given by the DataKind people on SciPy 2016, which is called Data Science is Software, which I urgently ask you to watch this talk. It's absolutely great. Then I've taken NumFOCUS just as a representative for the community, because I think the Python community in particular is like super helpful, and also I think that the open source libraries that were being developed are of a really, really high quality, right? And that's, you're not paying anything for that, you get that for free, and I think that's something which you have to be conscious of. And on the right hand side, that's actually where I took the screenshot from a colleague of mine, Torf, which I have, I've learned a lot about the extensions by him. And actually, I think it was a few weeks ago that he has shown me things that I could learn, and I think that's the usual thing that you learn from each other, and over time you are improving. Now I would start with one short slide about the technical side. If you're not interested in that, it's not so important. So what is important to know is that you start a process, a kernel process on your Jupyter server, which has a certain backend. For example, it's able to run Python code, maybe Python 2, maybe Python 3. I mean, that's a huge issue also. It could run R or something, but that's like addressable service that's being run. Okay, and there's a certain communication protocol, and you could hook in several front ends. So actually, you could open the same notebook at once, right? And this allows you to deploy the IPython kernel on a cluster and not on your home machine, and have the front end run onto your computer. These things are really well documented. By these things, I mean that it's using, I think it's the 0MQ, and it sends the messages over JSON. There's a well-documented documentation on how this protocol works. This is interesting for you if you want to write your own kernels or want to write your own extensions. It's not hard to do, okay? So don't be afraid, even if you're new in the world.
Hi, is this the Jupyter Hub thing, or?
No. This is Jupyter core and notebook architecture.
So it does allow multiple front ends?
Yes. And
why would one use Jupyter Hub then?
Actually, I haven't been using Jupyter Hub.
Oh, okay.
So.
All right.
But it's possible. So you may wonder. So I was wrong in saying you are hooking up the same notebook. You're hooking up 2 or more notebooks into the same kernel, and you are actually able to transfer information between them, which I show you in a second. There's a difference to have several notebooks run on the same kernel, a backend process. Okay, so I probably a miscommunication. Thank you for your question. More questions? Then I would go on. Okay, setup. Let's go to the practical part. So I'm actually switching to Chrome because in Firefox some key bindings are not working. So let me go to the leveling up Jupyter, it was right. Okay, cool. Under this part, so I have installed, if I'm checking the version in my terminal, I hope that everybody, so let me make this larger. Can you read this? A bit larger? This? Okay, let me clear. So everything all right. You can check whether you have Jupyter installed by simply running the command in the command line with the version, and I'm using this version for the Jupyter notebook, yes? Ah, it's a bit off, yeah. Okay, let's see. Okay, the window. Yeah, I will try that. Problem is that I have a window manager on, and this one is disturbing what I want to do. Okay, I have a bit on the left side. Okay, cool. Can you read it? Everything all right now? Yes? Okay, cool. So, and also what is important is to look at the Jupyter notebook version. If it's not 5.0 and it actually makes a difference, you can run the commands that I've written down here. I probably have to put it a bit on the right side. Here, this one, pip install upgrade notebook. Yes?
Could you also increase the font size on the browser?
Yes. Okay. And another thing that I wanted to show you, I'm working on Python 3.5, I think. If you're using Python 2, there's an easy way in Anaconda to install an environment that runs on Python 3. And the way you do it is, so there's a command, conda env list, which shows you all the environments that you have installed, right? The root one is a standard one, and it gives you the paths where these are lying. If you want to create a new one, you write conda create -n, the name, say py3 Jupyter presentation, yeah, and then Python equals 3, or you explicitly write down the version. Let me just write Python 3, then you press enter. And what it does now, it actually sets up miniconda. And that installation just contains the basic things that it needs to install other packages in a Python environment. So it's really, really minimal. I press yes. So this is a bit slow, but once this is finished, I will cancel it. Okay, it doesn't want to be cancelled. I will change the terminal. Once you have done that, it will appear on the list. Okay, that installation is probably broken, but what you can then write is source activate Python 3.5, for instance, or let's do Python 3.6. And the moment you're doing it, it will add almost on the shells information that you are in the environment right now. And now the whole package things are totally changing. So if you're writing pip freeze or pip list, then it will show a whole different ecosystem of packages, because it doesn't transfer the packages that you have installed on the other installation or pip list. And then you can start like install pandas, numpy. Now you have to install all the basic packages, sklearn, seaborn, standard, matplotlib, etc., etc. And don't forget Jupyter. Okay? And you can always check the Python version by writing Python -- version. Yes?
What did you do pip freeze?
Pip freeze list. So there's a difference. One shows the one installed by pip, and the other one installs all the shows all the packages in the Python path. So you can adjust an environment variable, the Python path. I think I have done that in my system. And this is a bit like if you know Java, like Java Home. These packages and modules, I will make that a bit larger, are being loaded into your Python environment, so to speak. And that's a difference. So, but I always confuse the two. I don't know which one is freeze and which one is list. I think list was giving you the whole Python path and freeze only the pip installation. Or could be vice versa. It's useful for debugging. So sometimes it can be not a good practice to manually set the Python path because you will clutter the Python libraries on every Python environment that you're using, and then you're breaking the isolation of your system.
So every environment with one variable, or one variable and then all the environments?
Yes. So that way. More questions? And if you want to deactivate it, I think it was supposed to deactivate or just deactivate. Yeah, you go back and you see that the environment was unselected. So if you're on Python 2, it would be a wise idea to switch to Python 3 now. So the next thing is when you have Jupyter, you can simply run it with Jupyter Notebook, this command. And you can set, for instance, the port, right, like 888, or tell him not to open a browser, which I will do so. So you could leave that out, then it will automatically open your system's browser. But I want to show you something. It will start and will actually give you a token-based URL. If you are starting this on a remote host, you may lose the URL with the token, and you can always, careful, I'm switching the console right now, increasing. You can always look that up by the command Jupyter Notebook list. You see all the Jupyter servers that are running on this node right now, and it gives you a URL. So my workflow is I log in into your cluster, my notebook is running all the time, and I'm writing Jupyter Notebook list. I get an URL, which is on localhost, but localhost would be the cluster computer. Now I have two options. I either give the IP or hostname of the cluster, or I do port forwarding from my localhost to the cluster. If you're not into network, this might be a bit confusing. So there are two ways. Either you address your cluster computer directly, or you are forwarding your localhost port to the remote computer. And then you can open this URL. So I will just so you also see the working directory that is like the root. And if we are copy pasting it into Chrome, so let me open a new tab. You should see this, and please run it in the repository that you checked out from GitHub. It is a bit small. This is still a bit small, right? This starts to be okay? Thumbs up or thumbs down? Thumbs down? Is this okay? Thumbs, okay. Yeah. Ah, you mean on the... No, I want to keep the right-hand side for now. So everybody please start your notebook server if you want to keep up. So you may probably not have the MB extensions tab, but besides that, it should look very similar to you. On files, you can assess the file system. On running, you can see the notebooks that you have started. And on clusters, we are not going into details for this right now, but on some setups, you can use this. We are not using it in our work. So from this you can go into the notebook directory and open the notebook that's prefixed by the 1. Okay? Questions? No? Who has started the notebook server? Okay. Seems like almost all with a notebook. If you have trouble, I think your neighbor or the next person wouldn't mind to help you. I mean, just ask. How far are we? Okay. So let's start. Okay, cool. So here still the one is added by the chapter of contents. I thought I had deinstalled it to show you a clean installation, but apparently that didn't work. And oh, I've lost my initialization cell. So I have a cell that loads all the libraries that I want to use. Heck, what do I do now? So you see when I move my button, there is this blue thing. This is, moves the selection of the cell that I'm in right now. If I type B, this adds a new cell below that one. I press enter, then it becomes green and I'm in the so-called edit mode. So it works a bit like Vim, it's a model editor. If it's green, I can now type something in, okay? And I want you to write percentage lot, okay? Space, snippets. It probably won't show you the autocomplete automatically, so you have to press tab. Snippets, simple setup.
How did you add the additional cell again?
With a B. And with an A you add above a new cell. Okay? And now I run this cell either by, it's some button here, I think this one. But we are cool, we are not using buttons, we are using shortcuts, so Shift Enter. And what it does, it loads the snippet file into the cell. And it comments out this. And your team will probably have a setup script with a version that's run here. And if you update it, you would rerun this cell. Ours contains like security information, connecting to the cluster, setting up path names, etc. Yes? Shift Enter. Okay, so it probably looks a bit different for you. You probably don't have this executed in 9 milliseconds, blah, blah, blah thing. This is the extension stuff which we will install in half an hour probably. So what does this do here? It imports some libraries, which I hope everybody of you knows. If not, you will probably know them very soon. Then this line tells matplotlib to output the plots into the notebook. So if you're doing visualizations, we are seeing that in a second, it will print them in the space. I want you to comment these two things out for now, because I will go into detail about that later. This will adjust the standard figure size for all plots that you're doing. And this is actually increasing like standard settings regarding the DPI, etc. for the plots, which makes a huge difference quality-wise, and we are going to look into details. And this is optimized for Retina displays, so if you're on a Mac, this setting is like perfect. This doesn't hold if you want to print it, actually. So, okay, and then the cell has to be run again, because last time we loaded the code, now we execute it. And you will see, did you see the star? The star means it's running right now. If we remember the architecture, the front end sends via this connection over the 0MQ the code of this cell, and the back end obtains this code and will put it in a job queue. And if the job is like it's first in, first out, and if it's in its place, it will run with the state the kernel has, so the kernel can have variables defined, etc. It will then execute the code and send back over the connection the result, and print it if there are any. Here it just sent back, yeah, I finished the computation, 2 seconds, which is like a bit suspicious. Suspiciously slow, actually, in my opinion. And this is the second cell that has been run in this notebook run. So we can always restart the notebook run to reset. So I can generate this. You see small ears, but a yes. Oh. So is this better? This is a bit loud. I hope it's comfortable and that I'm not talking too loud or too. Yeah, it's all right. I don't want to shout at you. So here I just wanted to showcase to you that I can run NumPy because I imported it before that. If I now press Command Shift P, I get like a spotlight like command thing, and I want to restart the kernel. On the right hand side you see the hotkeys that you would set if you're using Linux or yeah, Windows. I think it's Control Shift P. Some Linux or Windows, no? It works? It doesn't work for you? Does it open a private window on Firefox? This is why I'm on Chrome. Just use? Just P. Okay. And then I want you to confirm restart kernel and clear output. You are able to change the hotkeys and it will probably show. It's a great way to learn the hotkeys that way because you're seeing it sometimes and at some point you are able to memorize them. So now I've restarted the notebook, and if I now try to run this cell, it claims that the name MP is unknown. The reason is that I have reset the state of the notebook kernel. So I have to run the import cell again. And it's a good practice to write the notebooks in a way for reproducibility that you start from top to the bottom in the computation and that it should run. Okay? Okay. To continue, you can run shell commands from the notebooks. So this is, for example, the ls commands. Sometimes it's useful. People tend to write Python code to fetch like data files from outside, but you can just call wget or curl here on your system, and it will obtain any files that you need to perform your notebook. You can install dependencies, of course. I mean, pip is callable too. So you could run, install missing dependencies for your notebook. And you can also load extensions for the notebook itself for Jupyter. So this is, for example, the extension for version information. And you can use that to, so this loads the extension so that the magic is known. So actually, if these commands start with a %, it's called magic. And once you have done that, you can run version information on libraries. And this outputs the versions of the libraries you have been using, which is sometimes useful for other people to let them know which precise configuration you have used. Does the pip install work for you? Yeah? It's not large? but a package which I find much better is a watermark package, which prints like all information that you need about your current notebook run. Okay? Now, regarding modules, you can load modules from your process. So I have prepared some very simple code. Let me shift this a bit to the right. But where did I put that? Let me see. So model Py, and this is a very simple module that only contains one function that prints hello world with 2 typos. Okay. This file is in the same path as the notebook home server, so I can find it. It would be enough if it's resolvable in the Python path. It's even possible to add paths programmatically. You do it via the sys module. And now if we run it, it's with the typo. And now we see, oh, well, we have made a mistake and we would like to fix it. And if we run this code again, we see, oh, we are still stuck with the wrong hello implementation. Well, for that, there's a really generic solution. It's to use the auto-reload magic extension, which is installed standard on Jupyter. And then you write, so this is the time, I think it checks every 2 seconds, whether the modules have been updated, and if so, it updates the code that has been imported. And if we are now doing that, oh, it didn't actually. Wait, this is not as intended. Why didn't it update? I will check that at home and update it accordingly, because usually what should happen is that now the correct setting for hello world is maybe, so there's a way to debug it. If you want to see what's imported right now, known to the kernel, which variable you can run the magic who with a S. And you will have all the variables that are important with its types. And actually modules are variables too, and maybe I have forgot to delete something, probably. Excuse me? It could very well be, yeah. This could very well be, because so what you did was probably writing another from some module import hello. No?
I just saved the module file again. So basically I had the same behavior. I just saved the module file again after I did the auto loading, and then it got reloaded. Probably because only in that moment it realizes the timestamp has changed.
Yes. So let's try that. And I think I know why. Because it probably, once it starts, calculates a hash of the representation of the code that's being run, and it only reloads if this hash changed. So yeah, let's try that. I save something here. A typo. Here's my keyboard. So I've now changed the module, let's see. Yeah, and now it worked. Yeah, you're right. So we found kind of a bug. But usually when you're writing notebooks, you would just start with the auto imports and do not care about like doing the same in the same notebook. So usually what you do is you auto-import the libraries you're currently working on in your project, because apparently these will change all the time, right? And this makes development smoother. Questions so far? Yes?
The exclamation mark and the percentage,
Yes.
why are they there?
Why are they there? Okay, so the question is the exclamation mark and the percent. Why are they there? Okay, so the exclamation mark actually comes from Unix philosophy or like culture, and it's called bang. This means that yeah, bash scripts are introduced with a shebang, so a hash sign and an exclamation mark. So exclamation mark often stands for run this in a bash session, and the percentage is just the Jupyter or IPython people historically have chosen that as a special symbol. I think. Does somebody know whether it has a special meaning? Yeah, but I think make this a bit larger. Does this work for you? Does this work for you? Okay. Yeah, but I think that the percent sign is not that great for magic, right? It's not a magic thingy to have. Okay, you can also yes. Yes, because if I change now the code of the module, it will automatically import the stuff. So for example, at my work, I have code that I change all the time, and maybe I have a bug in there, but I'm using that in a notebook. I want to change the code and don't want to restart my notebook all the time. Okay, so... Yes. Yes. You also want that. You also want to keep the auto imports just for the parts that you are constantly changing, because otherwise you're wasting performance. More questions? You have also some possibilities to display resources from the outside. Oh, this path doesn't exist. Because I renamed it. And then you can link it. So this is useful. Some people keep the explorative notebooks from the ones that build models or results. And sometimes you want to link hypotheses from which you found during the exploration, and then it's useful to be able to exactly point to other documents. Okay, so let's go to some editing tricks. The problem is I have the extension with autocomplete, so it automatically starts autocomplete. If you're using it, so let's import scikit-learn. If you're writing something like scikit-learn dot, it won't show you this, but now press tab. And then it should show you the possibilities for autocompletion. So let me remove this with an X. I go back to command mode by pressing escape. I go back. Now I run this cell, add another. And if I now want to call this function, right? Usually when I now press tab, I will get some nonsense, which is not useful. But if I press shift tab, then I will get the doc string and the parameters of the function. Does this work for everybody? And it's like super useful. Shift enter. Shift tab. Yes? Oh, thank you. Yeah. So this is false. So I haven't told you, but this is a code cell and this is a markdown cell. If I now double click it, I'm editing markdown. And thank you for your correction. It's actually Shift Tab. Oop. And I can compute this also via Shift Enter, and then it will render. Yes? With X, while you are in edit mode. If you want to look up all the shortcuts, you can go under Help, Shortcuts, right? And you will get all the ones that you need. If you want to change a markdown cell to a code cell, you select it in the blue mode and press, I think it's Y. Yeah. And if you want, how do I change it back? I think it's M. Yes. And then Shift Enter, I can print it. More questions or remarks? Thanks, by the way. X is cut, yes. And then you can delete it.
Delete is double D.
Yeah, you're right. It's like in Vim. But I'm a guy, I always use cut.
You may not want to put it on a keyboard.
Yeah. Cool, thank you. More questions or remarks? Okay, I wanted to show you more, but now I need actually to have more overview. And actually, could you hold it for a sign, because now I need all my fingers. What I can do is also, so I'm sometimes, when I write code, I write many small cells, but at some point I want to merge them into one. So I can hold Shift and select all of them. And then it's, I always forget it, merge selected cells. And it makes one cell out of it. Okay. I can also split by selection. I think it's Command Shift minus. No, that's the wrong one. Control Shift minus. Yeah, it's Control Shift minus. Now I can split the cells into several ones. Okay. Thank you very much. Okay, and this is just like very simple. So let me try double D. Yeah, it works. I load a data set, which is a regression problem. So I have some variables. The target variables are numbers. I do a simple train test split. And train a random forest regression and print the mean squared error. Okay. And I typed that like in 30 seconds because of autocomplete. Thank you. More questions? What's random forest regressor? If we forgot what it is, something is, we can always write the identifier with a question mark. And if we run this, we get the documentation. Okay, directly from scikit-learn. We can detach it into an own window. And usually you open it on a different screen, read it, check stuff. Random forests are a bit more complex because you have several parameters to tune, which are all relevant. Okay. So far, so good. Who so far has learned nothing new? Oh, come on. I'm a bit unhappy because I wished that it comes a bit later, because we still have to... excuse me? Yeah. A question mark after the identifier. Shows the documentation. Okay. You also have pretty print functionality. So this is just a data frame I've loaded. I think it's a data set regarding California house prices, different areas. And you see that it's rendered in a certain manner. I think there was also a plugin where you can search and filter via this UI. You can also import and display animations, and I think it's super helpful. We are going to talk about pandas later. Everybody with me? Too fast? Too quick? Quicker? You want to learn more, right? All the tricks, all the gems. So to show you a bit of plotting, I have prepared here a scatter plot. Okay, just very, very simple, 2 dimensions. We are comparing the median income with the target variable, which I have put in the index. And you see it's being put in here. Usually PyPlot is like, it tries to model matplotlib, so it's like really, really old from its functionality. I make it a bit larger. And Seaborn is a great wrapper around it actually, which gives you great standard plots and also possibilities to change like basic plot styles. So you could, for example, remove the grids here for every plot, and it naturally wraps around matplotlib. So you just have to import Seaborn, you set the styles, you can look up the documentation, and it will change all your plots. Okay, which is super useful. And we now run the command which I commented out before, and if you rerun it, you will see that the quality changes. I actually, so they become larger, and they actually become more, the resolution becomes better. I think I prepared the two, yeah, this is simple retina. Oh no, I need both pens again. It's always, thank you. So this is retina, and this is no retina. So I think this plot is, maybe I should have made a vote. So forget what I said. Do you see the difference, or no, you don't? But it can be seen here that if you zoom in on the right-hand side, thank you, that the boundary here, you see the pixels, and you don't see them here. It's still not a vector graphic because it's, yes?
Sorry, what was the export again?
Excuse me?
Where was the export?
Oh, good question. So maybe you want to generate these both examples yourself. And the way you do it, you go here on the top. We haven't been talking about the UI so far. You can make notebooks and choose the kernels. I have one for Python 3, one with Python 2. You can open notebooks, make a copy, rename, save and checkpoint. Checkpoint is actually a history that's getting stored, and you can revert to that. Usually you're not using that because you're versioning it in Git anyway. You can save it as an HTML with the chapter of contents, but that only appears if you have the extension installed. And here's a DLS. And here are several exports, and I want to say a few words about that. So you can export the raw Python files, which will extract the Python code that you have written, append it, and I think it keeps the numbering of the cells as comments. So this is great. We always made the students actually hand in only the code, so we can read that one. You can export an HTML. You can export it in LaTeX, but for that you have to have a distribution of LaTeX installed, otherwise it will complain, and you have to have a pandoc installed. I have written that down in the repository's description. If you have worked with LaTeX, I think it's a great way to get a starting report. You would then adjust the quality. And you can here export a PDF via LaTeX if you have installed it. If not, please use the HTML export, and it will DL the notebook plus the output cells. Okay, so if you don't want to see the output cells, you have commands that you can run to hide the output. You could hide the output cells. You can thus adjust the export as you want. Questions? Okay. So, and you have also the graphics included. You have to be careful. They can become rather large, especially if you're doing high quality plots. So I'm the type of guy, I think my largest export was a few hundred megabytes because I had big data visualizations, and these can become really, really detailed. Good so far? Yes? We will touch that topic again because I think it's really important. So the question was, how did I make the plot bigger? And this command did some changes to the settings. So let me close all this. This was the documentation, and go back to our notebook. So good so far? Okay, we still have time. Do you want to have a short break of 5 minutes and we extend? No? Okay, good. I mean, I'm happy that you learned something and get something out of the talk, and I hope everybody got a really, really surprising moment today. And if not, we will still get to the hard stuff. So you may have tried to output several things, but it will just output the last line that you have written in your cells. But you can also change this. And you can use like this API of the core with the interactive shell and adjust the AST interactivity. So AST stands for Abstract Syntax Tree. It's a term from compiler building. If you don't know what this means, you don't have to know what it means. But what it will do, it will actually start to append all the outputs. If you want to omit outputs, you do that via semicolon. So, more about magic. You can list all the magic you have with list magic, ls magic. So you see there are tons of commands, and it's really, really simple to write new ones. It's not hard. There are GitHub repos that you can fork, take a look at, and write your own magics. So there are some file systems, some to put your code on pastebin. I think there's also one for gist from GitHub, these pastes that would send the content of a cell onto the pastebin. You can set environment variables. Version information is one that be important. You can communicate commands to the kernel, but you can also run cell magics like bash commands or render LaTeX, run JavaScript code, or render HTML directly. So I've shown you whose was listing all the variables that are known to the kernel process right now. With 2% you can set LaTeX. So this is a simple formula. If you have studied math, you probably know this. And most, I think, physics people know it. And there's computer science like most, chemistry most, biology some. And there's a minority of, in German we say Altphilologen, people who study classical texts from antique Greek, etc. And there's actually a community which uses LaTeX, but they are a total minority. Who has been using LaTeX? Yeah, great. I love this. Actually, I have the claim, this theory, that if you want to judge DS job seekers, you look whether on the feature whether they have LaTeX on their skill set on LinkedIn. Usually this is a giveaway of very, very good people. So you can also run several system commands if you're into that. So LSDU is Unix standard. If you don't know that, I would strongly recommend you at some point in your life to learn the Unix system details and the command line, because next to SQL, that are the two things that survived from the 70s in practical computer science. So always worth to learn them. You can set environment variables. This is really useful if you're working with Theano or a cluster like OMGP, like to make settings. If you need to set your which GPU you want to use, or other flags that often goes via environment variables, you can adjust this from the notebook. Okay, I've just written this down, but we have talked about this when the question arose how to connect with several notebooks to the kernel. You can actually globally store with the store magic a variable, and in the other notebook you can write magic store -r to obtain it. So the R is for receive. Do you want to see that as an example? Okay. So I define an integer x, no, and I open a different notebook. It should now know x. Okay, I should have shown you it wasn't defined before, but I think you would believe me, right? Okay, cool. But I have never used it. I mean, it's cool to know, but I think it's only worth it if you're starting a new notebook because your others got too long. But since I have the chapter of contents, I don't care about long notebooks anymore. You can, like the last result that you computed, to take over to the new notebook. Because if you're using a cluster and some computation take like 2 hours or the lunch break, it's sometimes not that great to recompute all the time, right? Okay. You can write code to a file. This is useful if you are loading a snippet, you change it in your notebook, then you can write it back. So you can write file, and it now wrote it to some code.py. You can check that. So here I asked what's the kernel tau, and I've showed you already that's the documentation. And it's a measure to, you have two ordinal features, and you want to measure like the correlation between them. The notion of correlation usually requires a real values, and this is just a statistic to do that for ordinal variables. You can also just look at the code of a file, inspect it by PyCat. You can run the code, so this produces graphics. This is sometimes useful to declutter your notebooks, and this tries to visualize, so two ordinal variables on each axis, tries to visualize the common occurrences. Okay. Good. Questions so far, or can I close the notebook? Who wants a quick rundown about the interface? No one. Okay. How are we in the time? Okay, we still have. I think we will manage. I close this. And now if I go back under running, you see it closed it. You can also shut down notebooks from here. Really important is that the kernel that's being used is explicitly denoted here. Okay, so let's open the next notebook. And actually, I want to close this because I want to show you the themes. Yes, leave. And for that, I have to restart the server. with Control C. And if we go back on the GitHub page, by the way, I've also prepared Docker images. One Docker image contains like the theme installation, and the other one, I think, installs extensions and shows how you would set up your own configuration of extensions, etc. And that way, you would have all your configurations for your Jupyter notebook in a Docker file. And when you have pair programming on with your coworkers, you can simply send them your Docker file, and you will keep your configuration. Okay. You can read these commands or look up the two Docker files here. This is the one with the theme, and this is the one with the extensions. Really simple stuff. Okay. Here are the commands. Themes. So it's actually pip install Jupyter themes. I like to use the user flag. Oh, 100 typing is fun. And once it's installed, you can run a command line tool that I've linked the page, has many commands. You can also change things like the font size, the font type that's being used. But also you have like several themes that sets like the overall environment. I think it's still installing, it takes a while. If it takes too long, I will start the Docker image container. Okay, it takes too long. So I have pre-built them, because if you would build them now, it would pull like several gigabytes. And we don't want to use that. And I've called them my Jupyter extension. Where's the one with the theme? Did I delete that one? Oh, I think I've deleted that one, sorry. Okay, so I can't show you. We have to wait for the installation to finish. So other questions so far?
The system magic you showed seems to output like a Python list. What if I wanted to use that list? How would I do that? When you use the system magic to run shell commands, it looked like it was outputting a Python list. How would I store that in a variable or something so that I could use it? Is there a simple way for that?
No, I think so. Actually, I don't know whether there is a way. But what you can certainly use is. So the question was, okay, you all got the question. So the answer is I don't know whether there's a way, but you could always use the sub-procedure, subroutine library from Python if you need that. Oh, it's installed. So, I always forget the name, JTT Chesterish. So it seems to take a while, and now I restart my Jupyter notebook. So you already see that the UI switched. This is a really dark theme, and now you also see, yes, it's really dark. You also see that the math font has changed, and actually here I showcased how you would plot whole equations in LaTeX. Right, this is a plugin that shows equation numbers. And yeah, that's that. So if you are into that, look up. Thank you. The Jupyter themes, and you will find some. Personally, I don't like it that way. I keep the I change the code fonts here to darker, but I don't change the overall view. I think, in my opinion, it's a bit too extreme. Yes. It's pre-installed. I've added the link to the Jupyter themes. If you scroll down on the README, you first have to call the JT command line tool. And if you look at the project page, there are plenty of themes. You can adjust the fonts. So I think nowadays there are much better fonts. For example, source code is one of the most famous one. There's Monofire, I think, by the Mozilla Foundation, which looks great, really great modern font. But then depends on your taste. And regarding tastes, you can always have a lot of struggles. Okay, so I would simply switch back, and you can check that at home if you're interested in that. I don't find this team topic to be that important, but if you want to reset everything, then what you would do is, I think, JT-R for reset. Yeah, and now we can rerun the notebook. Copy the link. I mean, you have to only do it once, right? And if you're working many hours, it's actually helpful to have good readable layout. Not that you should work much. Care for your families and etc. Okay, cool. So I wanted to show you just a small trick about pandas, and for that I need to get a data frame and maybe, wait, here. I find these dots super annoying sometimes in an analysis. If you have 100 columns or so, which sometimes happen in enterprise settings in your database, this would just not be shown, even though you can scroll, right? You have here a scrolling system. And if you scroll down, you see the same in the row. Sometimes this is helpful if you are in big data and have 1 trillion rows. Of course, you couldn't render them. But there's a way that you actually can set pandas to be more helpful with the rendering. Here I adjust the maximum number of rows and columns, also the width of the columns, and I adjust how many decimals are being shown in the floating points. And I think this is much more readable for explorative analysis. Or does someone disagree? And you can now inspect the data you have. And here I wanted to show you that you can also display HTMLs. Yeah, Jupyter is awesome. Questions? How much time do we have left? Okay, so do you want to make a short break, or shall we still have some visualization to do and the extensions and profiling and debugging? If you want to skip a topic, start to shout. So regarding the extensions, I have them already installed. The way you install them is the standard ones is given somewhere here. This command. Conda install -c condar -forge Jupyter contribution MB extension, and the contribution is limited to contrib. You can copy paste that. When you have installed it, please restart your Jupyter notebook. And if this has worked, you should see on your front page this tab with NB extensions. And the first thing that you want to start with, it will start like this: disable configuration for NB extension without blah blah blah, and you want to untick that. So now you're able to select all of these. Okay. I will now unironically go through them. So the first thing is that some of them have been added anyway in the new version, in the 5.0. That's why I told you to install the latest one, but I forgot which, so I'm sorry. However, the typical candidates are the ones that have compatibility older than 5.0. So this is now a debate which you can do. So you have plugins that do code formatting. If you have your project with PEP8 standards, you have code folding. This means if you have a method which is a bit longer, you can fold it. Then it doesn't show the whole line. I use the execution time, which you have seen. It's like a small line that shows you the historical execution time of your cells. You could have special initialization cells. You have highlighting of words if you want to mark something in your texts. Move selected cells is actually not there are no hotkeys for moving your cells up and down. You actually have to press buttons for that. What's rubber band? Yeah. With rubber band you can select several cells, which we did with the shift. Toggle line numbers. This is now standard in the book, so you don't need it anymore. Drag and drop of images, so you can import images into your notebook via drag and drop. This is sometimes helpful. Code font size is if adjusting your font size in the code. You have converter if you have Python 2 notebooks, so automatically to convert them to Python 3. Hotkeys for comment and uncomment. This is what I'm using often, and I'm missing from Vim and Emacs. Here gist, if you're using GitHub gist to share code. Using Python code in Markdown cells if you want to compute values and insert. Table of contents, this is a big one. I'm using it a lot. Hinterland is like this automated autocomplete. I'm using it. Some people don't like it. There are spell checkers, which you can also configure to the language you're using. There is like a MATLAB-like variable inspector, and you can summarize tracebacks, which I'm using a lot of Spark, and sometimes the stack traces are like this long and not helpful at all. Okay, these are the main. Here. This is a very cool installation that I also linked on the repository. This is a RISE package, and this actually exports a reveal.js slide set from your notebook. Okay. It should show up on the top. If not, then something is wrong with the installation, and you could ask me afterwards, and we here on the main page. Okay. No? Yes. If you Google the topic, you will find out. So the question was, is it possible to install these extensions without Anaconda? And the answer is yes. And it's documented. If you Google for MB extensions, there's a Jupyter documentation part. Or you just use my Docker images, which uses Anaconda. So you may want to switch. More questions? Yes?
Thank you. Is there any extension to use other markup languages, like specifically restructured text? Thanks.
Good question. I don't know, but I think there is. I think I've seen somewhere. So Google about that topic, but I think it's not really hard to write your own extensions. It's really not hard. And you can contribute. I mean, it's just some glue code you have to write that your Jupyter calls, your glue code calls some renderer and imports back the data into Jupyter. Someone knows? Yeah. No. Okay. Is it fine? Yes.
Yeah, so my question is if you know of a way to pass variables to an IPython notebook from outside, not from the environment, for instance, but in another way.
Excellent question. No, I don't know a way, but it should certainly be possible to write your own connector to the backend of your IPython kernel. I think you have to do some authentication to do and then send the data as a JSON. I fear that this is really inefficient because you would need to present your data in text format as a JSON. It could be possible to do it with Unix pipes somehow, but I'm not sure. This seems like a bit harder to do. But the simplest way would be to transfer it via the messaging system as a JSON. Or, I mean, you can also simply store it in an intermediate file format and then load again to notebook, but that's probably not what you want to do. You probably have some computation with a result in memory and you want to efficiently transmit it to the notebook.
Yeah, so my idea is that I want to use a Jupyter notebook as a template so that I can generate HTML out of it, but not always the same HTML, depending on what I pass in the command line.
Yes, there's an easy answer. So, if I understood you correctly, you have like a kind of parameterized notebooks. And yes, the notebooks are stored, if you open them with a text editor, you will see that they are stored as a JSONs, where the contents of the cells are stored in sequence. So you would simply write a JSON compiler or interpreter transformer, which should be rather simple. I think that you can write it. You shouldn't. I would just write it. You can do it. You will do it. I'm certain.
Thanks. My question is about version control. Last time I checked, JSON and diffs with Git didn't work really well. But you mentioned before that you kind of use Git anyway, so you have your repository, all your files are there, your notebooks are there. Is there been any improvement? Thanks.
If I now say excellent question, because I had the same question, it would feel a bit, I don't know, lousy. No, I've asked myself the question too, and I have working code to do version control probably with the old IPython. However, somehow I'm not really sure whether it has to do with my Mac, because the paths are a little different, where it loads the Jupyter settings from than with Linux. So I couldn't get it to work. The way you do it is you can hook in code in Jupyter, which runs when you hit the save button. And what you would do is automatically export to Python files and to HTML. And these are the ones you version. GitHub has efficient compare between HTML. You could also compare the graphics next to next, and of course Python files can be efficiently version controlled. But I couldn't get it to work with the latest Jupyter version. And I'm working on that because I need it for work, and I also put it on the slides that I'm working on that right now. It's the last slide, actually, second last. Yeah, and if somebody got the answer, please send me. Otherwise, I will post the solution to the repo. So watch it if you're interested in that question. More questions? We still have profiling and debugging and some visualization to do. I think, yeah, we can make it in time. Fine? Okay, cool. So we didn't go through many details, but you will see plenty of new buttons arrive once you have activated the extensions. If you press, for example, this, you see this is a chapter of contents. The way you do it, you use the markdown sectioning system. So this is the upper section. Let me create a new one. You actually have shortcuts. So 1, 2, 3, 4, 5. That stack for 2 for subsection. Shift Enter, and you see on the left-hand side that it updates. You can jump. As I said, I have huge notebooks, so you probably want to use these small arrows here that hides that subsection. Yes?
I'm just confused. Are we running in half an hour late?
Yes, basically everything was shifted half an hour. The lunch is at 1 o'clock, as I brought that.
I think we are over time, so
yes.
No, I'm just wondering if we're pushing everything else more, or
Everything is shifted half an hour since this morning because there was a huge queue at the registration.
right.
So no worries.
So wasn't it in Harry Potter that Hermione Granger got like this cloak where she could attend several lectures at once? That would be great for the next PyData, so put it in as a feature request for the next one. Okay, just really quickly. So first package is TQDM, and this adds a progress bar. So if you have a longer loop. There's also one, if you Google for Apache Spark progress bar, there's one that you can put it into your notebook and it will actually, how it's called, contact the master, how many tasks of your computation have been run so far. This is sometimes helpful if it goes into hours or days. You can measure the time that a cell that's being run with the percentage time. This is for the whole cell. If you run it, it will start to measure that. You can measure the efficiency of a single line with time it, and it will run it several times and show you the summary statistics. You can even parameterize it, I think, if you look up the docs. I don't know what I'm doing here. So let's just skip it. Maybe I just forgot to delete it. You can start, so here I have code that throws an exception. And I can actually, or you can actually use a magic debug, which would go to the last exception that has been thrown and starts a Python debugging system. So if you haven't been playing with that, you probably don't know it, but you can now, you have now several possibilities to go stepwise through your code. You could define new quantities or redefine things, and then I think you would want to restart it, and you can look at the memory, etc. For that, just check your Python book. You could also start PGB on a cell. So you're so you don't have to have an exception. It will just run the cell and then start the PGB process doing that. So let me exit it. I think it will start PGB all the time now, so you actually have to turn it off. Because the session, I think, survives several cells, but I haven't checked. Okay, cool. There's also Cython, which you can load as an extension. You can use that and then compare. Let's compare the efficiency between a Python implementation and Cython. And the Cython one should be faster. Spoiler alert. But it's very useful in some application. If you're doing really heavy linear algebra, sometimes it works wonders to either vectorize your code in NumPy or alternatively implement the routines yourself in Cython. Did it run? Did it complete? Why is it not? It isn't found. I don't know why this is the case yet, but percent sign p time should actually yes.
You don't need a setup file or something when you make Cython code. You can directly use it.
Yes. I don't know why this doesn't work right now. I have to look it up, but it should have given you like the Python profiler output, so you would see how much time your call spent in which method subroutine, how often, and how the distribution is of running times. This is useful to find the place where you want to start optimizing your code. Okay. I will have to check it why it doesn't work right now. Yes?
When I restart the notebook, the Cython code will be recompiled?
Yes.
Every time?
Yes. It can take a while. But I mean, that's debatable. But now you know you can integrate Cython directly. I mean, assume that you're actually developing Cython code before you put it in a file. Then it's great to have the opportunity to program it in your cell, in your notebook, and then you would transfer it to a file after you have debugged it. Yes? Question? No. Just the tiredness. It's like everybody wants to go to lunch. Just leave. So I give you a. So this is actually something which has nothing to do with the talk, but I did a short presentation on what visualization capabilities there is in Python. The libraries. This is an overview. Work through it if you haven't worked with Python a lot. I just as a present I gave you this notebook. Yeah, and so this is split cell. You can have stuff on the left and on the right hand side. And if you go through the visualization notebook, you can try, I think it's this one, this file, and toy around a bit with that. These are some standard settings I'm using for my visualization, and you can fine-tune like the DPI, like auto layout stuff, the figure size, the size of the labels, the size of the font. Use text is like almost nobody knows this option, but you can activate LaTeX for your matplotlibs. Why would you want to do it? Well, assume you have like a title with a very cool formula containing Greek symbols and stuff, or maybe an integral. Then you could plot it in the title of your plot or in the description. Since you often have to do work in a mathematical sense as a data scientist, this is sometimes helpful. Yeah, and you can also integrate other packages from LaTeX, compiling there. I did provide you with a similar setup script. What did I do? With a similar setup script for pandas and for Seabound, but this is really small, so there's often a setting that has to be or should be used for notebooks. Okay, I think we have 5 minutes for questions. I hope you enjoyed the talk. I hope you have learned something. And I hope that the selection of topics I made were sufficient. There's a lot to talk about, and you have at some point to stop. Questions?
Thank you very much so far. One last question from my side. Can you say anything about the state of Jupyter Lab? It's related to Jupyter Hub, right? So that's why. Okay, thanks nevertheless.
So, yeah. Maybe you want to go to JupyterCon. Actually, I still have more material.
If two users access a notebook at the same time, how does one user see the changes immediately of the other users? Is there a possibility?
Change what?
If one user works with the notebook and changes something, and the other user on another browser accesses the notebook as well, is there a possibility for the other one to immediately see the changes of the first user?
There should be the possibility, because in the architecture they are listening to certain channels, but I don't actually know whether it's implemented because I haven't tried it. When I'm simultaneously working with coworkers on the same stuff, so each of us has his own Jupyter Notebook server running, and we are doing pair programming with screen sharing to solve this problem. But I can investigate. I mean, it's a good question. Actually, I remembered that I still had some slides. Since some of you are students and don't know how it's... so, the first thing is if you're using notebooks in practice, it probably looks something like this. You're reading files, you're writing files, you're generating diagrams, etc. It's totally chaotic. And you probably want to have more of a pipeline view on your stuff, and you would start developing that in notebooks, and at some point export it into Python files, which you could programmatically run, and you separate cleanly input data from output artifacts. And there is the talk that I recommended you does this in a makefile way. I think it's worthy to see the talk and learn from it. Many teams are using naming schemes. Here's the versioning with Git control settings. I wanted to say one word about cluster deployments. So usually you have this set up in modern cluster deployments. Say you are on Cloudera or any other Hadoop distribution, you would run your IPython notebook on the cluster, which connects to your Spark master, which has access to distributed HDFS, so that's the storage layer. And if you are doing computations from your IPython driver, it communicates with Spark and says, please compute this. There's a number of Spark workers that the cluster can start, and there's actually a term called dynamic allocation. And this means that dynamically Spark workers can be started or stopped. And this depends, if you have a team sharing a cluster, this of course depends on the resource needs right now. And if you're using like the same cluster with your notebooks, you have like a lot of competition about your resources, but Yarn with dynamic allocation on Spark is doing a great job giving you the resources you need. Yeah, cool. And now we are done. More questions?